Thank you so much, Jim. Thank you so much. It looks like I was talking to myself for a minute there. Okay. As you guys know, my name is Al DiPaolo. I'm the voice of the Bobcat After Dark video series. No, it wasn't you. It was me. It's 4 o'clock. I usually do these webinars a little earlier in the day, so what can I say? Most of you all know why we're here today. Thank you so much, Jim, for pointing out the audio is down. And I'm just picking up where I left off. I've started a 2D job here. I've run the stock wizard. I've added some additional stock all the way around. Our next step here is going to be to set our zero position. Our zero position, when you're setting your zero position, BobCAD puts a bounding box around your geometry, so you can pick top, middle, bottom, around all of the edges of your part here. So for us, we're going to just put this in the back corner here. That should be fine. If we needed to change our X orientation or Y orientation or Z orientation, we can do so with these toggle switches. If you needed to align the coordinate system to the part, you could also use like a vertice, and go from there. Jim has a question. This is integrated SolidWorks webinar, not standalone. Yes, this is the BobCAM V6 webinar, Jim. If you're looking for the 3D boot camp that's on Wednesdays at 1 p.m. Eastern Standard Time, you can sign up for that one on the support page, BobCAD.com. Go to the training tab and then down to the webinars. Okay. All right. So we got our zero position here. Hey, no problem. We got our zero position here set up. We're going to go ahead and check it down. And we're going to look at starting to load some of the different tool paths that we might be using here. Okay. So the first thing that we're going to do here is face the part off. Okay. And one of the things you'll notice is, on this part here, I don't really have a sketch or a rectangle that represents the stock geometry or the stock size. Which is okay. I'm just going to pick up this loop here, kind of like what I'd been doing in yesterday's webinar. So we're going to go into the CAM tree, and I know this is different. Some systems, they have icons to load in your tool paths. Like if you're drilling or pocketing, you would go to an icon. With the BobCAM, this is all going to be found within the job tree. We're going to come into the job tree, right-click on Machine Setup. We're going to go to Mill to Axis. Within Mill to Axis, this is where we'll find all of our 2-axis machining options. We're going to come in here and go to Select Geometry. Okay. From Select Geometry, we're going to right-click on the edge of the part here, and we're going to go to Loop. We'll make sure that the loop is selected. That represents the geometry we want to face down. So that looks good there. We'll go ahead and check this down. And we've selected our geometry at this point. The next thing that we're going to do from here is go to the machining strategy. This is where we're going to choose which tool path that we want to use. We're going to come down here to facing. Facing is going to be the tool path that we're going to use here. Now, again, facing is a really common type tool path, one of your 2D tool paths. There are profiling if you're going to do profiling around the part. Inside shapes, outside shapes. You have your pocketing tool paths. Pocketing you could use for, removing material. You have open pockets from the inside out, the outside in, zigzag pockets. You have lots of different options. So you can come through here and you can pick whichever cycle that you want to work with. The other thing that you can do, if we look down here, we have our current operations and then we have our available operations. And using this little button here, we can take an operation from our available operations and we can push that over to this side here. And then that way, that is the tool path that we're adding to use for this feature that we're creating. Okay, so let's go ahead and we'll look at that some more with some of these additional pockets. On the face cycle, I don't really have much to do. I could do this. I could load 2 face cycles. So I could go face cycle and face cycle, right? So I could load 2 of them. I'll come in here and set my tool size. So this is a 2-inch face mill. This is a 2-inch face mill, all right? So I have 2 face cycles. One of them I'm going to cut with the tool off the workpiece with a zigzag starting from this corner with a 1/2-inch bump. All right, so one of them I'm going to do that. The other one okay, what I'm going to do here is I'm actually going to run it on the workpiece. Now, there's a very important thing that I kind of just did, and you might have missed it, and it has to do with this particular button right here. If we look at this button right here, this one says apply to all operations, okay? And this is one of the benefits that you get with working with a feature-based CAM system. This is our mill 2-axis wizard. We've loaded a feature here. We can go to the machining strategies and we can load in strategies. And you notice we have our facing routine here, and then we went ahead and loaded in another facing routine there, right? So we have two facing cycles. Now, if I want to use zigzag on the first face cycle and I also want to use it on the second face cycle, how would I do that? Well, you know, if I come down to, let's say, my patterns here, you know, I could pick what I want. Now, that's what this button is used for down here. This button is used to take a setting, like if I set this one to zig, right? So now I set it to single direction and I click apply to all operations, then the first face cycle as well will be set to zig. If I set the first face cycle to zigzag and I click apply to all operations, then the second one will also be set to zigzag. So this way, if you have multiple operations within a feature and you want to use the same settings, you can click apply to all operations and then it would apply to all of the operations. So hopefully that makes sense. But again, we're going to go back to our face cycle here. So we have our 2-inch face mill. The first one is going to be a zigzag routine on the workpiece. We're going to start from the front corner and we have a 1/4-inch bump. The second one, we're going to use the same 2-inch face mill. This one, instead of it being off the workpiece, we're going to make it on the workpiece. We'll do our 1/4-inch bump here. Give me just a second, guys. Okay, so we're going to go our 1/4-inch bump here. This one we're going to keep on the workpiece. We're going to use the zigzag. We'll go ahead and compute these two cycles. Let's see here. Let's leave like a small amount. It's going to be 20, so let's leave 10. And we'll compute. So we have this cycle, and then we have this cycle. Actually, it looks like I have them both going off the workpiece. So let's go back in here. We're going to go, this one is off the workpiece. That one's on. Let's recompute. Let's see here. Off the workpiece. Let's make it a little bit bigger. Let's say this one is on the workpiece. And we'll say 50% and recompute. Okay, so it looks like I'm getting the same result for both of these, so I'm not sure what I'm doing wrong here, but this is definitely, a lot of times what you might do is you might rough the first tool with it off the workpiece. It's not picking it up. And then the second one here, yeah, okay, I see. I probably don't have enough stock is what's going on. This one's actually machining with the tool on the workpiece, okay? So let's go back to the first one here. What I'm going to do is change my top of job to 0 and then recompute. Let's see. Let's blank this one out. Okay, so that one's not calculating. Let me look at my settings because I never make mistakes. Okay, so how deep is this going? Let's set our bottom. It's going to be this face right here. This is 0.2. There you go. Let's compute. Okay, there you go. So that is something that if you do not have, like if you have a tool that's too big to fit in an area, it's not going to generate your tool path. Okay, if you have, if you don't have material left in order to rough and finish, it's not going to, you know, we didn't get the rough cycle because there was no room for it to fit. So the numbers do have to work, but either way, let's get back to the point here. We're facing with one with the tool off the workpiece, and then we're finishing with one with the tool on the workpiece. All right, let's backplot this one here real quick. Let's go backplot. See what we got. You can see how this one is staying right on the edge of the part and the other one went off the edge of the part. Okay, we're going to launch simulation here and take a look at what's going on. So we're going to launch simulation. We can see our face mill. The first one starting off the material. The second one comes back and finishes with it on the material. All right, so we got our face cycle down. We're going to go ahead and rename this face cycle, and then we're going to blank it out. So we're going to just blank it out so we don't see it. So that's the first routine here. Now, the next thing that we want to do is we want to come in here and we want to cut one of these pockets. Okay, so we're going to come in, we're going to do mill to axis, select geometry. Now again, in yesterday's webinar, I was picking up faces like this. Even though they had cavities, I was still able to generate the pocket toolpath. Again, my go-to workflow would be to grab an edge here, like a tangency or a loop. That is usually the best method of selection for like profiling and pocketing. But it does look like we can come in here. Let's delete this all. So clear selection and pick this face. So we're going to pick this face up. We'll check it down. We're going to go to our machining strategy. This is going to be a pocket strategy. I'm going to remove the finish tool for just a second. So we have just the pocket routine. We're going to choose next. Let's set our tool size. We'll make this one a 1/2 inch end mill. You know, we're 750. The size isn't so important for the workflow. I mean, it's going to depend on what tools you have available and things like that. So we got our tool in there. We're going to do a pocket out. We'll do a 50% step over or 45% step over, something like that. Okay, we'll leave some stock on the wall for finish. We'll take it, let's say, in 2 steps, and we'll compute. And here you can see we get our pocket routine to come in here and to remove the bulk of the material. Okay, so this is going to take 2 steps. And then there we go. Now, the one thing we may want to do is add like a lead in, like we talked about yesterday. If you look at your leads, you can use your lead in order to ramp into the material or spiral into the material. Okay, I'm going to set this back to a single depth. Tim, if you give me just a second, I'll talk about avoiding clamps and things like that. All right, so we're going to do compute here, and we can see we get our spiral lead in over here, and then it's going to work its way down into the part and then move out from there. Okay, so that's our spiral lead in. If we come in here and we go to our leads and we change this to a ramp lead in, we have our ramp length radius, and then we also have our angle of approach. So let's compute the default, and what we're going to see is this little zigzag back and forth movement. The tool is going to zigzag back and forth in order to work its way into the material. Once it gets down to the bottom, then it's going to move around from there. If you want to make this movement larger, what you can do is you can change what the ramp length / radius is. So we're going to make this, let's say, 1 inch. And recompute, and now you can see it's moving back and forth at 1 inch as it moves back and forth. Or you could go even further. Let's see here. Let's go leads. Let's make it 3 inches and compute. Okay, so now what you're going to see is it's taking 3 inches to go from one side to ramp back and forth to get in there. And then we probably this is a larger part. There's 24 inches there, so we probably could go in. And let's go a little bit further. Let's say 7 inches, and then now you're going to see how it's going to ramp back and forth. Now you do see it's at 3 degrees. So we go there, and then we go there, and then we go all the way around. We could adjust the ramp angle too. So we can come in here, maybe make the ramp angle steeper, a 45 to get down in there. So this is just going to come in at a 45 to get into the material and then work its way out. So a couple of different options when it comes to how the tool gets into the material. For today's example, we're going to go back to our leads here. We're going to do a spiral. We'll set what our size is here. Hold on. Need to make this a little less aggressive of a ramp angle. Let's go to our parameters here. Leads, make this back to 3 degrees and compute, and I think we're doing all right. All right, so there we have our spiral lead in, and then it's going to pocket out that area of the part. Let's see, Tim said, what is the option that can be used to avoid clamps? Okay, well, if you had it's really going to depend. I mean, in this case, I have clearance all the way around, but if you had a clamp in here and we were dealing with drilling these holes, I'll show you how to use the hole groups for that. If we're in 3D machining, you could use check surfaces to avoid clamps. Okay, Tim? Todd had a question. Can BobCAD do a ramp lead-in on a curved edged arc, or does it need to be a straight edge for the ramp leads? So if you were doing a lead-in like within a circle or something like that, is that what you're asking? Will it follow the profile of the radius? I mean, a lot of times if I'm working with like a circular pocket or something, then you know, you could just do profile ramping. You could do helical milling. So give me just a second on that, Todd, and we'll get back to it. Okay. So, all right. So I have this this pocket set up here. All right. Let me backtrack. I did my face cycle. So off the workpiece, on the workpiece. This one, I did my pocket cycle down to this level. Now, here's the thing. You're never going to just like cut a pocket. You're going to have to finish the wall. You're going to have to break the wall. All right. So, or break the edge. So we're going to come back in here to machining strategies. So we have our pocket feature. What we want to do is add a profile finish. We're going to use that to finish the wall. And then what we're going to do is we're going to use an edge break. So we'll do, let's say, a chamfer mill to break the edge of the part. Our profile finish, we'll use a 1/2 inch finish tool. Our chamfer mill, we'll use a 1/2 inch chamfer tool. Our leads for our profile finish, we're going to use a blended lead, and we're actually going to use that same lead for the chamfer mill. So we'll hit apply to all operations. From here, I'm just going to compute the defaults. We'll see what happens. This gives me my pocket. This one's going to come in here, and this is going to finish the wall with our profile. And then this one's going to come in here, and it's going to chamfer or break the edge of the part. All right, so I want to get a better look at what's going on. So I'm going to launch simulation here. Simulation will come up. Now, when you're in simulation, one of the things that I generally like to do is with my workpiece, I'll make it either my workpiece or my stock. So I might show my stock but make my workpiece transparent. This makes it a little easier to see what's going on with your tool path and your material. I will also often turn off the display of the toolpath, or if I'm displaying the toolpath, I might change it to a segment section. So I only see a portion of it, or maybe a trace, or even a follow section. A lot of times it's just a segment, so I don't have a bunch of toolpath on the screen that is difficult to see. All right, we can step through to the next op. We're going to slow this down. We'll run through so that the first pocket routine is going to go in there and clear out the bulk of the material, come back and finish the wall, and then we're going to come back and break the edge. Okay. Now the thing with the edge break here, you can see that it actually didn't break the edge. There's no material being cut there. Or actually it's a very shallow value there. So one of the things that you have to pay attention to when working with a chamfer inside of a feature like this is you have the feature depth itself, but then what you also have here is you're going to have this chamfer depth, and that chamfer depth will be specific to the chamfer. So we can make it a little more aggressive and recompute, and that gives us our first pocket. Now, what we want to do is we want to come in here and we want to repeat the process on this side, and we want to repeat the same process on that side. So what are we going to do? We're going to blank out that feature, okay? We're going to come in here. We're going to copy the feature, all right? Once we copy it, we're going to paste the feature, all right? We're going to say no on the depth values. We're going to select our geometry. So we'll say this one and this one. Those are the two pockets that we want to attack, so we'll select those two. We'll check them down. We're going to edit our feature here. So right now it's got 20 thou below the zero, and then it has the total depth. What I want to do, actually, if I just finish real quick, you can see it's looking at the pocket as if it's starting from this top surface here, but it's really not starting from that top surface because we've already cut this this first pocket down. So we need to change where the start and stop of the cut is. So we're going to go pick top, and we're going to pick on this top edge here and check it down. Then we're going to say pick bottom. We're going to come down here to this edge here and pick that and check it down. All right. Now from here, I'm just going to compute the defaults. All right, because I'm using the same feature settings as the first 2-axis feature I'm using on the second 2-axis feature. Now, if I want to add a depth of cut, I can go back and edit. Maybe for my pocket routine, what do we have it going? We have it going 1 inch. You know, maybe that's too aggressive. Maybe we want to take it in 2 passes. We can come here to parameters, multi-step, okay, recompute, and then we've made that adjustment. Now, one of the things that can get you here is this value. Okay, if we look at this from a front. Okay, so let's go back and go to my trick that I often use is I'll get this in a top view, the view that I want. I'm going to right click on the screen, arrow down, set current view as top. Yes. Okay, so that just makes it a little easier for me to see what's going on. I'm going to go to a front view here. Let's change our viewing so we can see through. And you can see when it's wrapping up and going to this next section that it's not going all the way up out of the part. It's staying close to the part. Sometimes that is a good thing. Sometimes that is not a good thing. Okay, so how do we get this to go up further out of the part? There's a couple of ways to do that. One of the things that I usually pay attention to is if I have a negative top of feature here, what I generally do will add that number. I'll add that plus 0.52 to my rapid plane. Okay, by doing that, whatever negative top of feature value I have here, I add that to my rapid plane, and what that will do is put those that rapid back up and out of the part. Okay, that's one way to do it. Another way to do it is you could program these 2 features separately. So, you know, if I were to reselect my geometry, let me remove and reselect. I could pick one of these faces. Check this down. So I'm going to compute. All right. Again, you got to set your top and bottom of job. But then I could also copy this feature and paste it to the other side, because when you go between features, you'll always go to the clearance plane. In our case, the clearance plane is set to 1 inch. The clearance plane is set in your machine setup, so you can edit your machine setup, and you'll see your clearance plane value set right here. Let's see, Humberto had a question. Can you explain better on the operation face cycle about what the difference on Workpiece and off Workpiece? Sure, we'll go back to that. That sounds good. All right, so give me just a second, and we'll get back to that, Humberto. I got to get Todd's ramp in on a radius as well. Okay, so we have... so our clearance plane, if you want, the clearance plane is where the tool starts at the beginning and where it goes to at the end, and then it's also where it will go to in between features. So that's what the clearance planes use. This value, you're going to find it when you edit the machine setup. If you are in a feature, you'll see it displayed, but you cannot edit it. You have to edit it from the machine setup. Okay, so we got that. Let me come in here, remove, reselect. We're going to select this guy and this guy, check it down. All right, we are going to set our top and bottom of cut. So we'll say pick top. From there, check it down, pick bottom. From here, check it down, recompute. We have our rapids that are lower than I want them to be, so I'm going to come in here. I'm going to add whatever my negative top of job is to my rapid plane. I'll recompute, and I get them up out of the way. All right, so that gives me that. Now let me see here. I know I'm going to come back to this part in just a second. I know we had a question about these lead-ins. So, you know, it's just a different part that I have set up. I'm going to do 2-axis, select geometry. I'm going to just pick one of these counterbores here. In this example, I'm going to use a profile rough routine. All right, we'll set our 1/2 inch end mill. When we go to our patterns, what we want to use here, Todd, is you want to use this contour ramping. The contour ramping is going to be used to ramp and follow a profile. All right, so we're going to use contour ramping here. By using contour ramping, we can give it a ramp angle. Let's see here. We're going to go ramp angle 3 degrees. That's fine. Let me compute it. I want to see what's going on. All right, so what's going to happen here is the tool's going to start at the ramp, and then it's going to work its way down, right? So your question is, on your leads in a ramp, does the ramp, if I add a ramp to my lead, is it going to follow the radius, I believe is what you're asking. So I'm going to go ramp 3 degrees. We're going to recompute, and let's see what we get here. I don't see anything added by adding that ramp to it, because when you're helical milling, you know, it's really already ramping as it goes down, okay? What I want to do now is I want to get rid of this as a helical milling, and let's turn this into a pocket. So we'll close out the profile, we'll add a pocket in. All right, we're going to come here, we'll do spiral pocketing. When we do spiral pocketing, it's generally going to start right in the center of that pocket of the circle, right? So we'll do spiral pocketing, compute. You can see how the tool starts right in the center. So it starts in the center, goes down and around. If I add a ramp into here, so we'll go ramp, and then I set a value. So I'll say 1/4 inch and compute. You're going to see what it actually does here is it's ramping along the tool path that was created. Okay, so that's what we're actually seeing here is it's taking the tool path that's created and it's ramping along it. And based off of that length that I set it to, okay, so if I go back and I set my ramp length to, let's say, 1/2 inch, then what you're going to see is it will ramp along that initial part of that spiral pocket. Okay. That's when doing a ramp. Does that make sense, Todd? Yes. Okay, cool. Now, if we weren't doing a ramp and we went to a spiral, we could do a spiral here. We could set the radius size at this point, and then that will give us a spiral here. So you'll see it will spiral to get its way down. Once it gets its way down, it will work its way out from there. Let's see. When you select bottom of pocket, it pick top shows negative number from bottom positive. Is it supposed to be a negative number? No, it's not supposed to be a negative number. And that's another really good question. When you're in these features here, your top of feature could be positive or negative. It depends on where your machine zero is and where that pocket is within the job. But your depth is always going to be a positive number because it is a incremental value. It's like understood as an incremental value from your top of feature. Okay, so from here to here, this is an incremental value, and even though it's positive, it's going to go down because it's the depth. And I know that's confusing for some people because a lot of CAM systems force you to use a negative number there. For BobCAM, we know that it's going down. It says total depth here, and this value is just incremental. Incrementally, I mean, it's going to post an absolute, but it's measured incrementally from your top of feature to your depth. It's not measured from your machine zero or your setup. You know, it's not. If we look at this here, this little graph here, if that was your G54Z0, right? Your depth value, this value is not from here down. Okay. This value, your total depth, is from your top of feature, which is this one, to your depth. So this is an incremental value from here to here, okay? So that's how that works. So hopefully that makes sense. If it does, please let me know. And let's keep moving here. Keep moving on. You guys having a good week so far? I know I'm having a great week here. Lots of webinars this week. SolidWorks World 2018 wasn't there. Lots of people were. Maybe next year. We'll see. All right. Yes. Okay, good. Thanks. All right. So where am I at? So we did the spiral. We did the leads. We did the ramp. Let's get rid of this file. I go back to this file here. Okay. So we did our pocketing. We did our finish pass. And then we did our profiling. All right. So what else do I want to do here? I want to get into the simulation. Let's get in the simulation because this is going to have to do with machining order. And this is a really common question. We have our face cycle here, so we're going to We're going to do our face cycle. Once we get done with our face cycle, we do a finish pass on the face. Then we're cutting out our pocket here. We're doing the next pocket, roughing it out. We're doing the next pocket, roughing it out. Let's show our stock. Okay, so we do 1, 2. Now here's the thing. There's some Easter egg color coding going on here. Not my favorite color. Let's go ahead and change that a little bit. We're going to go to analysis here. Analysis, instead, if we want to change the colors, you could make it, blue or purple or whatever. But I'm going to go single marking, and I'm going to go to orange because that apparently is my favorite color when it comes to CAM, is this orange. Okay, so we'll refresh that. That way we can see everything with the same color. We'll start the cycle over again. We'll run this through. So we do our face, rough and finish. We come back and do our pocket routine to clear out the material. That's a rough on the one pocket there, a rough on the other pocket on the other side, right? Then what it's going to do is do the profile finish on that one. It's going to do the profile finish on that one. So what we have is tool dominant posting occurring right now, which means whatever tool is loaded in the job first, it will do all the tools that have that same job. The idea behind this is to minimize tool changes. A lot of users have questions about, how do they control the order in which the tools are posted. So let's go ahead and close this out here, and let's take a look at the machining order dialog. So we're going to go to milling job here. We'll right click, and we're going to go to where it says machining order. All right. In machining order here, we're going to have 3 optimizers. We have individual feature, individual tool per setup, individual tool, which would be across all setups. Individual tool per setup, this would be a tool dominant style posting. So you can see we have our pocket rough, profile finish, chamfer, chamfer. Okay, that will minimize tool changes. You can also run it as an individual feature. This is going to be the order that they're in the CAM tree. So this is face, pocket rough, profile finish, chamfer, pocket, profile finish, chamfer. Okay, so you can see the order is a little bit different there. Let's run it through a simulation. Why would you want to post in this order? I don't know. I think most shops are going to want to post tool dominant, but I could see there might be some in-process steps that need to occur, which is why you might do this. So that one did the pocket, did the rough, did the profile finish, and it did the chamfer. Now, some of you may be saying, well, hey, you know what? I really want to be able to see which tool was the rough tool, which tool was the finish tool. And right now with single marking, I can't tell what that is. So what we're going to do is go to views. We're going to go to analysis again. This time we're going to go to tool number. Okay, so we're going to go to tool number. We have tool number 1, tool number 2, tool number 3, tool number 4. So the face mill, we're going to make green. Okay, the 3/4 end mill, we're going to make orange. Okay, the 1/2 inch end mill flat, this is going to be the finisher. We're going to make this like a light blue, and then the edge break, we're going to make yellow. Okay, so now we've set up each of the colors of the tools that we want. We're going to repaint, and then this way it makes it really easy to see which one was the rough, which one was the finish, which one was the edge break. We'll restart. We'll cycle it through. There's our rough, there's our finish, rough, finish, edge break. Okay, so again, not the most optimal machining order in that particular setup, so we're going to close this down. We'll get back over into the milling job. We're going to go to current, what am I doing here? We're going to go over to the milling job. We're going to go to machining order. Under machining order, we're going to change this to individual tool per setup. We're going to say OK. All right, we'll run it through the simulation again, and now you'll see it will post tool dominant. If there's any questions, go ahead and fire them away. I'm going to get to Humberto's spacing question here in just a moment. Again, we're just showing some tool dominant. Now, in case you missed it yesterday, we do actually have machine simulation occurring. Some of you may be wondering why the tool is turning red or not. The reason why the tool is turning red is because I haven't moved the tool up out of the table. So if it Okay, so if the tool, I actually did, I turned off the checking group from yesterday, but if the tool runs into the table, it's going to show up red. The reason why it's actually showing up the color that it's showing up is because the chamfer isn't modeled in the part, so I'm actually cutting into the part. If I show the part model here, you can see that there is a bit of the material that I'm running into, and the color of the tool is indicating that I'm running into the part. So hopefully that makes sense. John has some questions here. It seems like the default rapid plane distance is hard-coded somewhere at 200. Is there an INI file somewhere where we can edit that? Same question, if it falls within the scope of the webinar, with the default max and min gradient values of deviation analysis and simulation, or at least a way to make it remember the last gradient settings. Okay, so you're talking about some defaults, and that's a really good question here. So there's a couple of things on that. I don't know, there isn't an INI file that I'm aware of that you can modify to change the clearance value. I think it's actually hex. So it's definitely hard coded in the background, right? So what John's asking here is if we go to mill 2-axis and we look at our feature, you can see this is 200. You can see this one's 100, and this one is 1 inch. So we have a 100 thou feed plane, a 200 thou rapid plane, and a 1 inch clearance plane. Okay. If you're looking for your preferences of defaults that you can set, if we go to settings, default here, okay, you have some tolerances that you could adjust, all right? So these are your default settings by your tolerance, right? But as far as your feature settings, any of your feature values in here, as far as rapid plane or these values here, they're definitely hard coded in the background, John. The way that you can define your own default would be using save and load feature. So similar to where I've copied and pasted a feature, what I would do instead is I would go to this feature and choose save. You could save it to a directory with some default values for depth of cut, width of cut, clearances, etc. And then when you load that feature in, it will bring in those values. So that's how you can default some toolpath settings for your features, is by using save and load. He's saying you do use save and load and they're not coming across. I'm going to take that as a no. So I'll definitely look into that one. Make sure I have a valid email address for you, John. If you could go ahead and type one in, that'd be great so we can connect on that. Save and load works. Yeah, save and load should work. So that would be the way to do it. But as far as defaulting it within the native features, then yeah, that's not going to happen. At this time, not that I'm aware of, okay? All right, so then the other question that you had to do with the simulation default. So when we get into simulation here, all right, and you're looking at some of these settings like the colors and things like that, when you start, if you're working in an existing file and you change the settings, John, then those settings should carry over. But if you start a new file, like if I go over to, let me go to this other file over here, and I get into simulation, I'm going to see the simulation default. So if I go to analysis, let's say tool number, it looks like I may have changed this one already. Or actually, it looks like it did pick it up, the green for the first tool. Let's see if we add another tool. But I know I don't. It doesn't remember the gradient setting. Okay. I know the simulation is. I'll have to look at it, John. I don't know if it can be set or where it can be set off the top of my head. So I'm going to have to look at that. So again, make sure I have a valid email address for you. Okay. Sound good? Do you have a mic, John? Let's see if you can join the conversation. Are you there? Can you hear me, John? You do have a microphone. I can hear you breathing. Say hello. No? Okay, no problem. No microphone, no big deal. No me breathing. Okay. All right, no problem, guys. Thank you so much. Hey, John, did you join the Facebook group yet? Not yet. If you're on Facebook, you should join the BobCAM for SolidWorks Facebook group, and you did join the After Dark as well. All right, so that's good. So let me see where else I'm at. Let me minimize this file here. Let's go back to this one. All right, so we've done our programming on this side of the part. Well, let's go ahead and drill out some of these holes. And we wanted to touch on facing. Let me go back to facing for Humberto. I'm going to actually just get rid of one of these cycles to make it a little bit easier, because I know that it can be confusing on how this actually works. So what we're going to do is we're going to look at on the workpiece, and then you have off the workpiece and you have a distance, and then you have on the workpiece and you have a distance or a percentage. So if we do off the workpiece and we say 0 and we recompute and we backplot this, what we're looking at here is that the tool center is off the workpiece, but no additional amount is there, right? So that's the first thing, is that if we look at this here, we say distance 0, and this is off the workpiece. The tool itself is offset, but no additional amount. If we add an additional amount and we recompute, then you can see it's further out. Does that make sense, Humberto? 0, it's going to be off the workpiece. If you added a value there, then it's going to go out further. Okay. The other one that is a little more confusing at first is on the workpiece. So if you say on the workpiece and you say 0 and you compute, let's go back here. On the workpiece 0, right? So we say on the workpiece distance percentage of tool diameter. So I say 0, it's still actually off the workpiece, right? Okay, so what you have to do is say how much of the tool you want on the workpiece, and that's by a percentage. So if you say 50% and recompute, then you can see that the tool will stay 50% on that workpiece. Now, some of you may be thinking, well, look, that's going to plunge right on the part. Well, if you're on the workpiece and 50% of your tool is on the workpiece, then what you guys got to do is you got to add a lead here. The lead length should be greater than the radius of the cutter. Boom. Now you get a lead so that it will come in off the part. But when it moves over, 50% of the tool will be on. Okay. If we come back here and we say 75% of the tool will be on, it's just going to keep moving what that amount is the other way, okay, by the percentage of the tool. So does that make sense for on the workpiece and how percentage of tool works, Humberto? Let's go ahead and get a thumbs up on that. Very good. All right, so that knocks that one out. Now, another one we were talking about was avoiding clamps and things like that. You don't have, you're not going to model in clamps and select them, and the software automatically move out of the way, even in 3D. In 3D, you can select surfaces of your clamps and have them avoid it with check surfaces. That's how you would do that. In 2D, if you're drilling or some of these other cycles here, let me blank them all out. Some of these other cycles here, you can actually use our hole groups in order to, like if you had to jump a clamp or something like that. And that does come up from occasion. So we're going to do drill hole. Okay, we're going to do select geometry. Now, in this example, I don't want to have to select all of these cylindrical faces like this, all right? So I'm going to delete that. Let me clear my selection. I can pick the whole body, so I could just pick up the whole body, and it's going to find the holes for me, all right? There is some filtering. If we look down here, options, so you have minimum hole diameter, maximum hole diameter. So if you had a bunch of different hole sizes in there, you could use this filter to say only find me holes that are between these two ranges, all right? So we're going to pick up the whole body. Let's erase this. Let's go to that. We'll check it down, and the software is going to find these holes for us. We're going to choose next here. We're going to add a strategy. So we're going to say process a hole and compute. And then here you can see we've drilled all these holes. That's one way to select it, is by the whole body. Another way to select this, we could go to our feature tree here, and we could grab our features out of the tree. That would be another way to select it. Boom, boom. Now, if you want to force the tool to go to clearance to jump a clamp for drilling, okay, you can use your hole groups here. We can come in here and edit this feature, and this is our hole group here. So our hole group is going to show us, you know, our if you hit Control and the center mouse button, you'll get a pan here. This is going to show us all of our hole locations, and right now this is all in one group. Okay, so we're going to take this and we're going to break this whole group, and then what that does is it gives us all the individual holes that is that have been selected here. Okay, so these are all the individual holes. So what I'm going to do is I'm going to select that one, and so 12, and let's see here. Let me. I don't know what I'm doing there. 12 and 17. So it's 12 and 17. We're going to regroup. So we made them their new whole group. And then we're going to go through the rest of these and we'll regroup them. Okay. So this is a way for you to change the rapid plane between these holes. Okay. So that's basically what's going on here, is we're going to change a rapid plane between these holes. Let's get rid of, where's that other one? It doesn't look like it got picked up in the group. We wanted 12. Yeah, those two are out. We're going to regroup these. Okay, so we've created two different groups. We have this as one group and we have this as another group. I don't think I'm demonstrating this right, but that's okay. I'm going to recompute here, and what you're going to see is that in between these two different groups, we're able to get the tool to go to clearance. Okay, so that definitely does not demonstrate that very well because of some of the order of cutting here. I am showing that as it goes from one group to another, it is going to clearance. But we would need to group these a little bit differently. I think I might want to group one section like this, you know, another section like that, and the ones in the middle here. But using your hole groups is really to help you drill holes that are on different Z levels, but you can also use it to force the tool to go to a different clearance between your hole groups. So that was one of the other things that I wanted to show here. Now, let's go ahead and remove this. Let's reselect. We're going to pick up our feature here. We'll check it down. We'll compute this one. We'll compute that one. All right, so we get everything that we're looking at. Now, in the future, in future versions of BobCAM, you will get a toolpath editor in here. It's going to be super cool. It's coming. Not quite yet, but it's coming. With that toolpath editor, you could pick on a couple of these lines and just pull them to clearance. It does make it super, super quick. But with that being said, we've done our facing, we did our pocket, our inside pockets, and then we drilled some holes here. Now what we're going to do is we're going to flip the part over, and we want to get to the other side, and we want to clear this material here. Okay, so we're going to add another setup. So we'll come in here, add another setup. That's under additional functions, insert setup. Okay, when we get the setup in here, we're going to edit this. We're going to pick our 0 position. And then we need to align our axis. Okay, so to align our axis, we're just going to flip our Y. So we get Z pointing in the right direction. We can change what work offset we're in. We're in work offset number 2, and then we'll check it down. All right, so now we have our second setup here to cut on the other side of the part. Now from here, what we're going to do is just profile around this. We're going to say no on any edits. We might need to face down the part, break the edge, or profile. I'm just going to put a profile around the part here. So we're going to right-click, Mill to Axis, select Geometry, come over to one of these edges, right-click. Okay, we're going to do Select Loop. We'll make the arrow go in the direction of the loop that we want. We'll check it down. With our profile routine, we have our profile rough, profile finish. That looks good. We can look at some of the different settings, maybe the size tool that we're using or how it's going to lead into the part. In this example, I'm going to do parallel. Let's make it a little bit bigger. So we'll say 1, apply to all operations, recompute. Okay, I don't have anything. So what happened? So what's happening right now is the toolpath is actually on the inside of the part, so we can't see it. So after you've calculated your toolpath, you could come in here and change your view to more of a transparent view so you could see, okay, toolpath is there, but it's on the wrong side. All right, so we can come over to our default chain start point. That will determine where the tool is going to start cutting from and also the direction the tool is going to go in. So we're going to right click on this. When we right click on it, we'll see the preview come up, and this arrow over here is representing where the tool would be start cutting from. So what I'm going to do is modify. I'm going to put it on, let's say, this edge here. I want to make sure that the arrow is pointing the right direction, so you just click on it. And you can change what direction it's going in. So we want it going clockwise for climb milling. We'll spacebar, not spacebar, we'll check it down, and we'll compute the rough, and then we'll compute the finish. Okay, so I may want to change my lead in a little bit further, so we'll just make it a little bit bigger, 1.5 inches, apply, compute, and then here we can see the tool's going to come down. And then it's going to work its way in. Now, the problem with this one here is the tool isn't wide enough to clear all the material. So we could either go to another tool size if we wanted, or what we could do is what's called side roughing. Okay, so side roughing would allow us, we could say, all right, we could say measure, and let's go from here to here. Okay, so that's 1 inch. So we can come in and edit. We could say patterns, side roughing, 1.1 or 0017 or whatever it was. Okay, so we can set that, and then we can tell it how many passes we want it to take. So we're going to say take 3 passes, all right? We'll compute, and then what this will do is take multiple passes in order to work its way in to remove that material around that outside edge. Okay, so this one's called side roughing. That's one way to do it. Another way to do it is we could do a pocket. There's this chamfer here, so I'm curious of whether this an open pocket would work. So let's give it a try. Let me blank this out real quick. So we'll blank this. We're going to do 2-axis, select geometry. I'm going to pick this face, check it down, machining strategy, pocket. We're going to do a advanced pocket, and I'm going to compute. See what it does. Okay, it is able to pick that up. So, side roughing is one way to accomplish this, where we tell it how much material and how much per pass. You have to measure. Sometimes there's some guesswork, and if it's irregular thickness around the part, it may not be the best scenario for you. If you are using open pocketing, it can pick up if you have a surface shoulder like this, it can pick up the edge of the stock and actually do an open pocket. This way, you know that it's going to start off the material, finish off the material, and work its way in. And you can do that as a more traditional offset style, or you could do that more so as a adaptive style. Okay, so from here we have this routine and this routine. Now, if we just want to verify these 2 routines here, what we would do is go back to our first setup, turn the posting off. We'll be in our second setup here. We'll run our simulation. Now we're only going to see one of the setups being processed. All right. If we turn both of them on and run it, then we will see both of our processes running. And you can see here with our side roughing, like I was talking about, we're missing some of the material in the corner here, and that's really a good example of why the open pocketing or adaptive, either parallel or adaptive style, would be a better approach to clearing the shoulder here. All right, so let's close this down for a second. Let's go ahead and turn the posting on this setup on. Okay, we will just change this real quick. We're going to change the strategy. We'll get rid of the profile rough. We'll add the pocket finish in there, or I'm sorry, the pocket routine. We'll make it advance. We'll go ahead and compute. Nope, I got the wrong geometry. Picking the edge didn't work in this example. I got to pick this face. So let's go ahead and remove, reselect, pick the face, check it down, compute. Okay, and that gives us that routine. And this one I'm going to turn off. We'll go to simulation, and this time we'll see both setups. We'll see the first one, and we'll see the second one. Again, my name's Al. I'm the voice of the BobCAD After Dark video series. I really appreciate everybody spending some time with me here today. I know you guys are busy, and time is money, so I do appreciate your time. As always with BobCAD, you can expect fewer steps, better cuts, and more profit. If you guys have any questions, go ahead and fire away. Otherwise, that will be day 3 of the BobCAM V6 2D milling kickoff. So I appreciate everybody spending some time with me here. Brian, thank you for showing up. Charlie, Eric, Hugh, Humberto, John, Camille. Nice to see you in here, Camille. Richard, Ted, each and every one of you, I really appreciate you spending some time with me here. I know you guys are busy and time is money. So I look forward to seeing you in more webinars. We have plenty to go still. If you haven't signed up for any of our Facebook groups, go ahead and do that now. Just search Facebook and just go to Facebook and search BobCAD and group, and you'll see your options there. Otherwise, I look forward to seeing you guys all in the next one, and I hope you have an amazing day. Thank you so much.